Hi, I hope everyone is doing well. In today's video we'll be going through relative frequency. Have a pen and paper ready to take down some notes. Make sure to stick around to the end as there are some questions for you to attempt. And if you want to find your way back to the channel, make sure to subscribe to stay up to date with everything related to your Maths GCSE. Let's get started. So what is a relative frequency? Relative frequency is the estimated probability of an event occurring. It is found by conducting an experiment or collecting data and comparing the number of times the event occurs with the number of experiments conducted. We can say relative frequency is equal to the number of successful trials divided by the total number of trials. So for example, if I played a game 100 times and only won 60 of them, we could estimate the probability of me winning a game as 60 over 100 or 0.6. So this 60 over 100 or 0.6, this is what we call the relative frequency. Now that we know what a relative frequency is, let's go through expected frequency. So expected frequency is how many times you would expect to see an outcome in a given number of trials based on the relative frequency. So it is expectations based on a relative frequency. We could therefore say that the expected frequency is equal to the relative frequency multiplied by the number of trials. So for example, the probability of a player scoring a penalty is 0.72. So 0.72 is the relative frequency. The player will take 50 penalties. So this 50 penalties is the number of trials. Work out an estimate for the number of times the player will score. So we are trying to work out the expected frequency. What you would do is the relative frequency multiplied by the number of trials. Therefore, you would do 0.72 multiplied by 50, which equals 36. Therefore, if the player takes 50 penalties, we can estimate that he will score 36 of those penalties. Let's go through a few more examples. So as before, expected frequency is equal to the relative frequency multiplied by the number of trials. A farmer sows 300 flower seeds. So this 300 is the number of trials. The probability of a seed flowering is 0.7. So this 0.7 is the relative frequency. Work out an estimate for the number of these seeds that will flower. So all you would do is 0.7 multiplied by the number of trials, which equals 210. So from these 300 flower seeds, you will expect 210 to flower. Let's go through another example. The probability that a biased dice will land on a 5 is 0.3. It is going to be rolled 400 times. So this 0.3 is the relative frequency. This 400 times is the number of trials. Work out an estimate for the number of times the dice will land on a 5. What you would do is you do the relative frequency multiplied by the number of trials. Therefore, you would do 0.3 multiplied by 400, which equals 120. So if you rolled this dice 400 times, you will expect that it will land on a 5 120 times. Another important aspect which you should know is that the sum of the probabilities of all possible outcomes is 1. So whether it is a fraction, a decimal, or a percentage, it will equal a whole. The table below shows the probabilities of a landing on a color when a spinner is spun. The probability of a landing on a red is 0.15. The probability of landing on a blue is 0.3. The probability of landing on a green is 0.25. And the probability of landing on a black is unknown. Complete the table. So what we need to understand is that all of these probabilities added together will equal 1. Therefore, we'll put the value of black as x, which is an unknown, which is what we are trying to work out. Therefore, 0.15 plus 0.3 plus 0.25 plus this value of x is equal to 1. Once you tidy this up, you'll get 0.7 plus x equals 1. What you would do is take this 0.7 to the other side. If on this side it is positive, on the other side it becomes negative. Therefore, x is equal to 1 minus this 0.7, which is equal to 0.3. So therefore, we can replace this value of x with 0.3. What I would suggest is always add up these numbers at the end to make sure it equals 1. 0.15 plus 0.3 is equal to 0.45. 0.45 plus 0.25 is equal to 0.7, and 0.7 plus 0.3 is equal to 1. Therefore, we know our answer is correct. Let's go through another example. A vet records the animals he sees over a week. The probabilities are recorded in the table below. So the probability that he will see a dog is 0.25. The probability that he will see a cat is 0.1. The probability that he will see a hamster is 0.3. And the probability that he will see other is 0.1. Complete the table. As we should know from the previous slide is that all of these probabilities should add up to 1. Therefore, we'll put this x as this is an unknown, which is what we are trying to work out. Therefore, we can say that 0.25 plus 0.1 plus this value of x plus 0.3 plus 0.1 is equal to 1. Once you tidy this up, you will get x plus 0.75 is equal to 1. What you would do as this 0.75 is positive, once you take it to the other side it becomes negative. So x is equal to 1 minus 0.75. X is equal to 0.25. Therefore, we can replace this x with the value of 0.25. So probability of seeing a rabbit is 0.25. Another question is, in 1 week, 150 animals are brought in. Work out an estimate for the number of hamsters that will be seen. Again, what you would do is you'll find hamsters, which is 0.3. You'll times it by the number of trials, which is 150. You'll do 0.3 times 150, which is equal to 45. Therefore, in that given week, we can estimate the number of hamsters that will be seen is 45. Let's go through some more difficult questions. In a bag there are red, blue and white counters. The table shows the probability of picking a red counter. So the value of blue and white is unknown. When we have two unknowns like this, we will generally be given extra information. The probability of getting a blue counter is the same as the probability of getting a white counter. So if the probability of getting a blue counter is x, the probability of getting a white counter will also be x, as the probabilities are the same. What we will do then is 0.1 plus this value of x plus this value of x is equal to 1. Once you tidy this up, you'll have 2x plus 0.1 is equal to 1. You'll take this 0.1 to the other side. Therefore, 2x is equal to 0.9. The opposite of timesing by 2 is dividing by 2. So x is equal to 0.9 divided by 2. Therefore, x is equal to 0.45. Therefore, we will replace this x and this x with 0.45. Again, we can check our answer. 0.45 plus 0.45 is equal to 0.9. And 0.9 plus 0.1 equals 1. Another example, again we have a red, blue and white. We have only been given red. The probability of getting a blue counter is twice as the probability of getting a white counter. Therefore, if we say that the probability of getting a white counter is x, as the blue counter is twice that, it will be 2x. Therefore, we can say that 0.1 plus 2x plus x is equal to 1. Again, we'll tidy this up. 3x plus 0.1 is equal to 1. We'll take this 0.1 to the other side. Therefore, 3x is equal to 0.9. We'll divide both sides by 3. So x is equal to 0.9 divided by 3. Therefore, x is equal to 0.3. What we will do is, as this value of white is equal to x, we can replace this with 0.3. And as this value of blue is 2 lots of x, this will be 0.6. Again, we should check our answer. 0.6 plus 0.3 is equal to 0.9. And 0.9 plus 0.1 is equal to 1. Therefore, we know our answer is correct. Here is a question for you to attempt. Please pause the video, have a go, and we'll go through the answers on the next slide. There are only red, blue, white, and black counters in a bag. The table shows the probability of a counter being taken out at random. The probability of a red was 0.1. The probability of a blue was 0.3. The probability of getting a black counter is the same as the probability of getting a white counter. Work out the probability of getting a white counter. Therefore, we can say that 0.1 plus 0.3 plus x, which was this value for white, plus this other x, which is the value of black, would have equaled to 1. Once you tidy this up, you would get 2x plus 0.4 is equal to 1. You take this 0.4 to the other side, so it's 1 minus 0.4, which equals 0.6. So 2x is equal to 0.6. You divide this by 2, so x is equal to 0.6 divided by 2, therefore x is equal to 0.3. So the probability of getting a white counter is 0.3. Again, you can check your answers. 0.1 plus 0.3 is equal to 0.4, 0.4 plus 0.3 is equal to 0.7, and 0.7 plus 0.3 is equal to 1. The second part of the question, there are 240 counters in the bag. Work out the number of red counters in the bag. Again, what you will do, you will find this relative frequency, which is 0.1, times by the number of trials, which is 240. So 0.1 times 240 is equal to 24 red counters. Let's go through a summary of what we have gone through today. We have gone through what relative frequency is, and we know that relative frequency is equal to the number of successful trials divided by the total number of trials. We have gone through what expected frequency is, and we know that expected frequency is the relative frequency multiplied by the number of trials. If you do have any questions, you can leave them in the comment section below. If you have been able to benefit, please share with others so they can also benefit. Hopefully I'll see everyone safe and sound for the next one, and as always, take care of yourselves.